Welcome to Tech Command Investing, where technology meets leadership. I'm Alain Gavin, managing partner at Scion and venture partner at Carista. This is the show where we explore how emerging technologies are reshaping business strategy, security, and the future of digital ecosystems, all through the lens of maximum deterrence and European resilience. Today, we're zooming in on a subject that almost nobody talks about, but underpins far more than we realize: the advent of spectrometry infrastructure. This industry still operates in many cases as if it hadn't come out in the 1980s. Siloed devices, proprietary formats, manual reporting, 6 months delays. I mean, how could it be still there, yeah, in a world where that now demands real-time intelligence? And yet spectrometry sits at the core of some of the most critical verticals shaping sovereign capability: harm prevention monitoring, defense and CBRN awareness. In this case is chemical, biological, radiological, and nuclear, environmental toxins such as asbestos, and we might talk about that during the podcast, counterfeit luxury authentication, and then also well beyond that, air quality control, water management, industrial production quality control, oil and gas, mining, food and beverage traceability. In other words, material truth. My guest today is Brad Elsbury, CEO and founder of Unknown Labs, a company based out of Luxembourg, building what may become a device agnostic intelligence backbone for material identification, connecting crucially those national laboratories, customs agencies, and governments into a real time interoperable detection grid. So, what happens when a local scan in Africa becomes a continental alert in seconds? What happens when fragmented detection becomes synchronized intelligence? And what happens when network effects turn local harm reduction into sovereign infrastructure? And because this is ultimately all about this use case of prevention monitoring, it's about owning the interoperability layer across critical material detection. It's about data compounding across borders. And for investors, it's about recognizing when a niche application is quietly becoming critical infrastructure, the kind of infrastructure that once embedded across the first 21 countries and 100 plus nodes becomes extremely difficult to displace. Brad, welcome to the show.
Hey, thank you so much. We appreciate it.
Yeah, let's just dive into it with your origin story and how you got here. Before we talk about spectrometry infrastructure, let's start with you. You didn't wake up one morning wanting to modernize an entire industry. What was the moment or series of moments that led you here? Was it frustration with legacy systems, technical insights, regulatory bottlenecks, a real world incident that exposed systematic flaws? What made this problem personal enough to dedicate your life to solving it?
Oh, that's a really great question, and I ask myself that every day. No, no, no. It was actually an accident. Uh, in the past, I came from aerospace hardware and ComSat satellites in Luxembourg, so I did that for quite a while. And a friend of mine was in the, let's say, luxury industry, and he slowly convinced me to come into this spectrometry. So they use, let's say, 4 different devices from different manufacturers in different countries, and I took that as a challenge in that field. So, and that's how it started. And my mom didn't raise a quitter, so
Yeah.
and, and so that's where we ended up. So, we had these issues of different manufacturers having their own silos. We had issues of, let's say, network devices, and it was uh, it was a good thing that we did. Let's say we overpowered on the data side, on the network side. So we use cutting edge technology to process that data and link it to devices. So something that used to take 8 hours, we can do in 3 seconds, and that's our key advantage. And I think that's the powerful part about what Unknown Labs does, is speed.
Hmm. And then maybe moving on to the inflection point, you initially explored gemstone authentication. When did you realize this wasn't about one niche vertical, but about a structural flaw on how material truth is captured, stored, and shared? What shifted your thinking from product to infrastructure?
I think that's we looked at the, let's say, the gem market, and we realized it was such a small and niche market. And from there, what I found out was, in the gem world, we have four different manufacturers. We have four different techniques in spectrometry. Um, and what we found fairly quickly, back in June, July, is there's a ton of other verticals. And as we mentioned, in the CBR&E is one of them. The environmental toxins is one of them. Narcotics is one of them. Every one of these different organizations or B2B uses different devices. And those devices are siloed. And even within some organizations, you have different manufacturers doing different things in one business. And it happens so quickly where we already could connect those devices to the infrastructure. And we found out very, very quickly that it turned into a B2G, business to government type application. And that's where everything started coming together. Before, you have a business, or let's say a certain agency that has 10 devices. Well, on our level, we connect thousands and thousands of devices at one time. They all are working together. So at any point, and this is what I was saying with our speed and our infrastructure on our data, we can have up to 25,000 devices at one time sending data.
Mm.
And, a normal spectra, one person shoots 10, 15 spectra a day. We can do 1.9 million uh, at any given time. So I think that was us talking about overkill and where's the applications that you can use that. And that's when we went from B2B with 15 to whole countries or whole nations, to use our infrastructure. So we're set up for scale. And I think that was a key moment that we had, at the very beginning of the company, was to do this type of infrastructure. And it paid off. The risk paid off. And um, never regret that moment of paying that money.
You've described your company mission as harm prevention. Is your motivation technical, commercial, or ethical? What keeps you awake at night on this problem?
Very recently, in June, about that time, we found out that the market segment wasn't, let's say, big enough for multiple players. So we got into the harm prevention, of drug checking, let's say, in Luxembourg, and it made me feel good to get back to community. Especially, we're using cutting edge technology in a field that's, let's say, underfunded, in a bit, and to bring them to 2030 in terms of technology, and fairly rapidly. So what keeps me up at night is we're not fast enough on the market for, preventing death. So I think it's wholesome
Mm.
feeling, and it's what we should be doing.
Yeah, I totally agree. I mean, totally on board with you on that one. Yeah, we should be preventing death.
Yeah.
Um, but you mentioned before that there was a structural problem that most people don't realize spectrometry still operates in silos with manual reporting and months of lag. Why has this fragmentation persisted for so long? Because we have networks, we have LAN networks, we have all sorts of networks in the computer area. Why has this persisted so much in spectrometry?
I think it's like early adoption. You look at anything. Um, Excel files still rule the world because that's what everyone's used to. And in these other fields, they're caught in the early 90s. They're caught in 2001. And it takes them so long to, let's say, adapt and change. And and that's what Unknown Labs, our company, is bringing. Hey, instead of an Excel file, let's just create an API key out. And then you don't have to do this manual typing in. Um, and that's what kind of our USP is in this market. When we go to the specific hardware, they still send Excel files via email. We create that platform where they test it 2 seconds later. The OEM has the results and they can do the diagnostics on it. And that's something where, we can speed up that industry, material identification and other things, much faster, especially in the field. So, and
Mm,
that's something that's super important.
yeah. And coming on to the use case that you mentioned, harm prevention with counterfeit pharma. Um, Before we walk through a harm prevention example, I want to be clear that this is just one vertical where the problem is visible and urgent and very urgent. The same infrastructure applies across copy and paste across toxins, defense and CBRN, gemstone authentication, air quality control, water management, oil and gas, mining production control, food and beverage traceability. So let's dive into this first example of counterfeit pharma. How do the network effects work there in practice?
I mean, we see it in counterfeit pharma. We see it in, let's say, illicit drug use, things like that, drug checking. We can overarch it as drug checking. Um, we just had an example the other day where, 60% of your counterfeit pharmaceutical drugs are in Africa. And to us, that's a big deal. Pharma companies, their names on the label, but yet it's not the real products. And again, harm prevention. Can we stop a person that meets their prescription from taking a drug that can potentially harm them? And how can unknown labs give them that diagnostic in 5 seconds? And we can do that with our type of infrastructure. And we can use the OEMs that, let's say, the pharma brands trust. And when there's a new, let's say, new anomaly on the field, we can spot that instantly and bring that back to analyze, and then shoot it back to devices to make sure that when it comes up again, we can see that. It's the same for, let's say, Europe. In that sense, there's not a lot of counterfeit pharmaceutical, but there's other types of illicit drugs and things like that where, hey, you're not get what you've been told you have. Uh, Check it. We don't want you to end up in the hospital. We don't want to waste resources, let's say, on the public health and safety. And that's something that's super strong. We want to keep those patients out of the ER and make sure they're okay.
Mm-hmm. And so, what's your unfair advantage? What is technically unique about Cassiopeia, which is your platform? Is it the device agnostic integration layer, the spectral matching algorithms, AI driven structural similarity detection, or the way your cloud architecture compounds intelligence across borders? Because you're able to look at a spectrometry from one spectrometry or from another and compare. What's your USB?
Our USP is speed.
Yeah.
We do we do uh, like temporal data networks. So, for an example, we don't do traditional SQLs. We don't use cloud infrastructure for AWS. We're using a new type of data analysis, um, and it's pretty proprietary. And what we can do is, things that used to take 8 hours to do analysis now take around 15-20 seconds. Uh, and and that is our USP. And it's not like this technology is new for the company that we have. They use it for electrical grids already existing. So we just adapted that technology for spectrometry. So we get a live feedback on the device, which is fairly new for the industry. I would say it is new for the industry to have live feedback like that. Uh, Today they use cell phones and libraries on the phone. That's the high tech that you currently see today from the big players, let's say.
So trying to understand the network effects that you're creating here, which is quite wow. You've described multiplicative intelligence resolution. What do you mean in practical terms? At what point does this become infrastructure rather than software? How does this create network effects across the different applications, the different devices? Can you maybe walk us through a bit how that works and maybe you want to bring in a figure in there?
Yeah, perfect. I mean, for those who are listening, we have a figure up here where when we take one device, such as this is a simple OEM off the shelf device. Um, One manufacturer makes 10, 15,000 a year. And what we can do is once we have one on the network, all the other devices that use the same, they can use it for different fields, such as the CBRN, such as narcotics, such as environmental, counterfeit pharma. They can actually connect to that network and use the device for other needs than what's applied for. So one device turns into 10, turns into 15, turns into 20, 30, 100, so on and so forth. We've seen the network effect already several times. We would go into a place, we would walk out with 10 other, let's say 10 other companies that are interested in the same thing, that are dealing with the same topic. And what we do is we have one device from an OEM. They're using it for a specific task in a certain sector. And then a national lab would come on board. And what we do is we connect those two together with their two different types of machines. So HPLC and NIR. And we
Mm.
link those two graphs up, and then it strengthens the system for the next players. So France has that set up, and then you could go to Germany. And now those two systems are talking together, building and building and building. And they can relay information back and forth to strengthen the system. So every player that comes on board with the different machine types can actually talk to each other and enhance. So that's how we create the network effect. Um, Also, in sheer numbers, some OEMs just want to do their entire infrastructure with unknown labs. So they have some 5,000 devices just because they want to be a player and all their different verticals. And they can actually sell more product to their customer because it has a variety of things they can do already. So we're speeding up, let's say, R&D and the product, the USP. So the lower players, people that sell 200, 300 devices per year, they can compete with the people that do 5,000, 10,000 devices. So we're putting them on the same level in terms of technology. So I think it makes it a square playing field for, let's say, OEMs. And on the other level, national level, with laboratories and things like that, we can give them infrastructure to do analysis and diagnostics. So instead of going to online forums and seeing some spectral data, it's all there in one source. And they can compare with the analytic tools in our platform, things they would probably have never seen otherwise, or would take 6 months. And then we add the AI layer on top of that. It's a whole nother dimension of, like, let's say, prediction modeling. So
Mhm, mhm, mhm. So, I mean, with that explanation around network effects, I mean, why should investors care? Because this is infrastructure and a lot of cases critical infrastructure and not SaaS. Where are you today in terms of deployment, countries, nodes, interaction, and why should serious investors be paying attention now? When does a vertical solution become a continental intelligence substrate, basically? Yeah.
we have a little traction. I mean, for us as a company, um, you, I'll take 5 minutes on this one. Is what we found out in B2B and things like that. We were fairly strong. Now we're on the next level, let's say B2G type applications. I think why, um, you know, let's say continental intelligence and being serious about deployment, we're playing on, most of these OEMs and these B2B, they have 10 devices. That's it. If
You
you're
have
if you're
what?
lucky enough, 10 devices.
Oh,
Let's
10
say 10
devices. Yeah.
for
Mm.
deployment.
Yeah.
And that's in a building somewhere in a laboratory. They don't really need that. But when we talk about large scale things, let's say counterfeit pharma or customs, or even, looking at whole cities after war, post war, you're looking at multiple devices, you're looking at multiple threats. You're not looking for explosives. You're looking for residues, you're looking for chemicals that are potentially harmful to people. And how do you link all these different manufacturers up in that situation? How do you GPS coordinate where that threat or toxin is? And that's super important. And that's the layer that we're giving. So we're actually kind of on top of there, looking to see where the problems are.
Right.
Um,
Mhm.
in terms of traction, uh, in let's say the harm prevention, our traction's extremely strong. In the past couple of months, we're already deploying cross borders. We did that in gemstones in Asia, a couple, 3, 4 units, something like that, which was B2B. Then B2G. Now yeah, there's a lot, and we're crossing to I think 21 different countries fairly soon. We've already started installing systems in different locations. Um, yeah, and that's just for two verticals. The third, of course, was environmental. We just did a massive contract this morning, so I think we're okay for a while. So, but that's just for toxins. And what's like, let's say asbestos, you have the DDT situations, recycling, those type of people are recycling, uh, DBT or flame retardants from the 60s. They're recycling them, or the government's telling them to recycle. They recycle it, and then it ends up in a new home, and 20 years later, someone has cancer. Could that been prevented? And the answer is yes. Uh, and that's what the unknown labs infrastructure does: is we mark, we identify, we can confirm with lab in one platform, so we can prevent these things from happening in the future. And it's not a new, let's say, you know, yeah, let's keep it at that.
Yeah, yeah. And then,
Traction's good.
yeah, and then maybe moving on, from the traction bit and maybe expanding a little bit because of your market expansion beyond the counterfeit pharma and maybe also toxins in buildings. It applies for infrastructure, right? So across, as I said, toxins, defense, air quality, water management, oil and gas, mining, gemstones, food and traceability. Which one of these verticals do you think could scale fastest? And which could become strategically most important, do you think?
I mean, we all know what's going on uh, overseas and across the way. I think that's something that's super important for unknown labs is do not play the defense game to enforce. There's a lot of things that happen after the war when it's over and it's out of the news. People have to rebuild. Um, and unfortunately, I mean, for us, we are more of a humanitarian approach. So we identify the toxins to get rid of them, to rebuild countries, rebuild cities, things like that. Um, right now, let's say it's an arms race between, let's say, the drug market and defense environmental, uh, but all are interlinked. Um, I honestly believe that the narcotics one will be the fastest growing, fastest scaling. Um, Defense, we're not going to see something. I hope we see it tomorrow, but we won't. 2027, 2028. So hopefully these conflicts will end sooner rather than later. So
Mm-hmm. And maybe, I mean, that's is a nice segue onto the next section, which is around defense and sovereignty and real world defense applications. Um, where does this sit in the new defense stack? Could this realistically plug into CBRN detection systems? Is that in battle or after battle, post war toxin identification, dual use early warning systems? Give us a real world scenario where this is materially changes the outcome.
for unknown labs, we're good at detecting anomalies and predictions and things like that. So, anyone can do let's say, uh, a pure industrial chemical. And what we find is when you see on certain areas, people make shift things. They make their own type of explosive. And how can our how can our system identify and track down who made the device in different regions. So it's more of a forensic situation.
Mm.
You'll never see, let's say, our technology at the front of a robot. You'll never see it at the front of a robot going in to disarm a threat. We're just
Mhm.
not meant for that. And that's what I'm saying is we would never be on battlefield. We would be post-war, or let's say post-conflict in this situation. Um, Also, do use early warning systems. This is something that comes up once in a while. Is you have a major toxic spill, or let's say, uh, we saw it in November in the United States when a UPS aircraft crashed and there's jet fuel everywhere. Okay, how far did that jet fuel go? Is it seep into the water supply? Do they have issues with residual things going on? What else happened? And so
Mm.
our prediction modeling, we can kind of see, hey, this could have leaked into this water channel. And that's something that we're more doing is harm prevention for later steps, the 6, the 12, the 24 months out when people start to inhabit that space again. Um, and that would be like a real world outcome uh, that we could do. So it's not limited to post war. Dual use is a big topic for us because we apply the same techniques in defense as we do for environmental toxic recycling. So it's hand in hand and it goes together.
Mm, mm, mm,
Was
mm.
that was
Yeah,
that a good
and
answer?
yeah, yeah, and always a good answer, yeah.
That
And,
was a legal good answer.
maybe talking about strategic, dependence versus sovereign control, Europe talks a lot about digital sovereignty. If the spectrometry layer remains fragmented or controlled by non-European OEM ecosystems, what risks does that create? Is this about efficiency or about sovereignty? What have you seen?
Well, for us, I had the discussion about data sovereignty all the time. Um, what is data sovereignty? I've had so many conversations is, will the country share the information? Yes. On paper, maybe, is what they
Yeah.
always say. So it always depends on what it is. Um, uh,
Um,
Again, our technology, the minute we see a conflict, I mean, hope uh, the countries that we would deploy our technology to for defense will hopefully will not be on Europe soil. And in those situations, really doesn't matter about what data we pull from a post-war um, a post-war conflict, and that's something that's very key. Other verticals, yes, um, narcotics, things like that. Data sovereignty is important, but what data are you taking? There's other instances of other companies taking too much data, but there's nothing else that country can do, so they have to comply. Uh, and that's our strategic advantage is we're in it for the spectral data. We're not in it to take personal information. And that is a moral stand on the maps. That's
mm,
a we have that come up every day. Um, so we only take the data that's relevant for, let's say, enhancing the OEMs and the systems and the infrastructure. So we leave that to other parties. For those tuning in via audio, I'm going to share my screen now to walk through a visual demo. I think what's super interesting for Unknown Labs in this regards is what the OEMs didn't have before was, let's say, fleet management, let's say on the B2G level. So usually when you have an OEM, they just have their devices and they don't connect to other devices, their competitor. And what we do is we try to bring them together. So when we're analyzing, let's say, a country or different labs and things like that, we integrate other types of devices, and then we can see what's going on. So this one, for instance, is a Esch Technical Laboratory. And what we can do is we can monitor the spectrometer, and so you can see what's going on and the last scans that something have, that the last scans that that device has, and that's how you can kind of monitor what new pharmaceuticals are coming out or counterfeits, or we're looking at anomalies, let's say in illicit drugs or toxin that's in a certain location. And that's what's super important for us is we instantly can get that feedback and link up different devices together. So for instance, here we have what's called an FTIR, and we attach it to a Raman device, and those two reports are linked up automatically. We also go into more, let's say, technical devices like an HPLC, which you'd only see in a lab. And this is why our platform is so strong. Um, is we're linking up all these different devices, all these different places, all these different organizations, and we're only taking the spectral data and what the material is. And so if anyone else is connected to that network, they can see what the other players are scanning and make sure that, hey, this anomaly that I found, was it anywhere else in the world? And it helps them identify it. Um, and that's what we see with like Chat GPT and these LLMs. They're not all that accurate for this type of thing. They need a good data set to be accurate, and we hold that data. Uh, and that's what we can use for our outlook in 2027, 2028, is to do these type of deep dive research into different, let's say, different materials on the market. Um, and so, and that this is more for laboratory field management. The other image that we kind of had, this one is just for environmental. We could use this in the CBRNE application, so post-war scenarios. Again, this is just a demo of an image, but let's say you have disaster relief. Um, you can deploy different types of manufacturers. So it could be, let's say, the big players or a small player, and we can start to group where these toxins are found on a particular site. So we can tap into GPS and actually mark out where the hazardous cleanup needs to happen. And we do that automatically. Um, not necessarily for the radioactive side, but more the corrosive materials, I mean, for this case in environmental, the asbestos and things like that. So we can start grouping these different toxins in different areas. And that's what makes our platform so strong, is everyone uses it and everyone benefits.
And you can imagine a world even within a sovereign European state, for example, agency would say, well, it operates within our agency. And so everything operates only within our agency, which is what you have as well. You have islands of interoperability. I mean, because of your integrity or data integrity that people are looking for.
Yeah. And for, let's say, I call them high risk applications, for, let's say, certain intelligence groups. Uh, they play by a different game, and we're debating on going into that. But again, we're more focused on the harm prevention and the infrastructure for, let's say, less risk than intelligence, or enforcing is what they say.
Mm,
So, and I think that's the fine line that we played on the labs.
mm, mm. Now, looking ahead, with increasingly powerful AI models, I mean, the LLMs seem to be getting more powerful by the day. And projects like AI 2027, I'm not sure if you have read up about that, where autonomous scientific reasoning is to reach a certain level by 2027. And even just today with OpenClaw and the advent of AI agents, what happens when your spectral database compounds over years, and how is that affected by what's happening on the AI front?
I have this debate all the time too with the data architects. Um, we look at how we strengthen the system, and it's through validation. So you can put bad data into a AI model and you'll get a bad result. Um, for us, we're building the blocks with laboratories and ground units to enhance and also to strengthen what that spectra is. Um, we projected at the end of 2027, 1.9 million spectra from different verticals. Um, we would never, I don't want to say never, because we don't use AI to identify materials. We use solid math problems that have been around for 100 years. Um, Now, what we do use AI for is, let's say, prediction modeling. which is super important, especially when we're watching an anomaly going from one country to the next, or when we starting to do this. I go back to the airplane. Where's that toxin going to go
Mm. Ver ver
in the ground? That's what we're going to use the prediction model for. Um, and I think that's super important is how and where you use AI. Um, and so I'll give you an example in harm prevention. We work with a few organizations, and everyone gets it- people that are using our systems. They're not paramedics. They're not doctors. They don't have a PhD in analytical chemistry. They're
mm.
normal people.
Yeah.
So when a drug comes up, we're not going to give you the scientific name. We give
Mm.
you what the street name is. Hey, this is ibuprofen. Hey, this is Xanax. Hey, what is Xanax used for? And the AI can kind of say, oh, this is Xanax. It's used for this cutting agent for this certain thing. And they can inform the person that's using the tablet, okay, this is what it is, this is where it comes from. And that's how we use kind of AI, and where we can use it to kind of identify and inform the person behind it. Now, again, we don't use that for diagnostics. We do that to inform the person to make, let's say, cautious steps.
Mm.
But we don't use it for diagnostics, just
Mm.
to be 100% clear so I don't get in trouble in the medical cluster.
And then maybe on final reflections and the bigger picture, if listeners want to better understand the world you're building towards, the intersection of infrastructure, intelligence, and sovereignty, what 1 to 3 books would you recommend and why?
From my stance as a CEO, I look at, those things, infrastructure, intelligence, and sovereignty. And I think for me, we have to take the approach of the harm prevention. And it's more of the psychological things that go on. And you might not agree with that. And for me, I deal with, me personally, I deal with these situations where people are helpless. They
Mm.
can't do things and they're looking for help. So more, the books is like, yeah, I Am the Untold Story of Success. Okay, that's entrepreneur's book, and how they
Yeah.
won. And another one that I find interesting, I'd read it when I was a kid. My dad made me read it. Is How to Win Friends and Influence People,
Mm.
and
Mhm.
and, and that's something more telling stories about the emotional, kind of the business side, and and I think one that's super important lately is Humans of New York. I know it's so cliche and everyone sees it, but in our line of work, beyond the infrastructure, intelligence, and all of that, it's at the end of the day, we're helping people, and we can't forget that because they depend on us.
And then the final thought or final question, if we sit here again in 5 years, what will have surprised us most?
I'll be a farmer. No. Yeah, yeah. Yeah, no, Alan, I think what's super interesting, uh, let's just say the last 6 months, um, we went from 3 devices doing gemstones in different countries to building infrastructure for thousands and thousands of devices to do different tasks. And that was in the last 6 months to now building infrastructure for uh, organizations beyond B2B. Um, in 5 years, whoa. I, I, I
Will you
hope,
be the juggernaut?
I, you know, the one thing that I've learned in the last, in the, let's say in the last 5 years, you can't do it alone.
Mm.
And what I found very interesting with that is I just show up. I do the
Yeah.
day to day, and people come along with ideas that never thought were possible, and they push you. Um, and that's where in the last 6 months, that's where it is today. Uh,
Mm.
and I'm excited to meet the new the new people that will help me go to the next level. And the World Health Organization, for instance, we look at UNDA, European Drug Administration. We look at those new people that need help, and Unknown Labs is there for them. And they tell us where do they want to go, and we build that infrastructure around them. So who knows? Like, I've had some wild conversations about satellites in
Right.
a couple, and before you know it, we're doing NBAs and going to a field. Um, so every day's a bit different for us.
Well, that's great. Yeah. Well, thanks for that wonderful insight into critical infrastructure for spectrometry. Yeah, let's hear about what you've done in the next 5 years. Yeah.
All right, I'll be here. No, I'll be Luxembourg, I think.
All right. Thank you.
No problem, Alan. No problem.
If you're an LP interested in learning about space tech, defense tech, and security, including cybersecurity investment opportunities, let's chat.